So, Hanny, here's the thing about networking. You need to know it. Now, if you want to be a developer, probably not. I mean, you should know certain things. It's okay. It's all good. I want to justify you needing to understand it. Think about the network as the ground your computer is standing on. It's the pathways, the interconnections that bring computers together, right? I mean, it's what the modern web and the modern world is built on right now. It's built on a network. You're connected to a network right now. List a time that you are not connected to a network. I'll wait. Never. If you have a smartphone, you're connected to your cell network or somebody's Wi-Fi. And I'm sure you know what an IP address is. Every computer that sits on a network has an IP address. And this IP address is being assigned by a server called DHCP. DHCP leases IP addresses. And a server, I need you to understand, is not specifically a hardware thing. So you can think of a server, a lot of the time people think of like a supercomputer or something like that. But really it's a service. I think of it as like in a restaurant, you order food from your server. You're a client, they're a server. Your request hits the server and they go and fulfill your request. That's kind of how I look at client server. So yes, normally will there be more powerful hardware involved? Yeah, usually because I'm just fixing my face here. Because the Killers are an American rock band. Did you hear Siri? Why is Siri talking about Killers? But anyways, yeah. So servers, I'm in the weeds there with that. So servers are a service, right? It's not just hardware. Usually, though, your servers run on more powerful hardware because they're more relied upon. So, to really kind of start off with networking, I like to start with just understanding what are the different devices on a network. So, for everybody that's listening at me right now, no, your router or your software provides services. When I say a service, think about a network as a neighborhood. Hold on, that's kind of distracting. So when I say service, when I'm talking about IT, I'm talking about some type of program that's delivering information or delivering an address to a client. A client is a computer that's requesting a service. So for example, when we go out to YouTube, for example, and I hit enter, HTTP is the service, right? And there's a web server that's delivering a web page, which is written in HTML, over the web to your browser, which is a web client. Yeah, HTTP is the protocol that delivers the actual HTML. So you could also consider HTTP a service. Excuse me. I try to kind of personify everything I learn in IT. So I think about like with a service, if you think about a neighborhood or a town as a network, you just think about your network neighborhood. Then you think about what are the different services offered in a town, right? You think of a fire department, hospitals, restaurants. Those are all services, right? Maybe even sewage and all that. But on a network, there's different services that computers request, right? So web pages are just one of them, and that's used in HTTP. DHCP, Dynamic Host Configuration Protocol, is what delivers IP addresses from a server to a client. So like you maybe have never statically assigned your computer with an IP. I know I've never actually assigned my phone an IP address because it's getting one for automatically. Your router is usually getting one automatically from the ISP, unless you're paying for a static. But then even then, if you're paying for a static, it's a reservation that's coming from your internet service provider. So you can even in Windows, in Windows you can open up command prompt, or in Mac or Linux and do Linux it's ifconfig or ipadd. Windows it's ipconfig, shows your IP addresses or your IP address on your internal network. For you to be able to communicate, you need an IP. So I'll ask you this, Hanny. Do you remember giving your computer an IP address? Because if you don't remember giving it one, then it got one automatically. Are you running Windows or Linux? That's another question. Yeah. So you got one automatically from DHCP. So the way that you would do it in Windows, Mac OS, okay. There's an option. If you were to search, if you go up to search and type network, it'll pull up, and it's like this little, I think the icon is still that, like, it's like a gray world with connections in it. That's what the icon looks like. You can go and see that your network card, network controller, network interface controller is actually set to receive an address automatically. And that's happening via a protocol called DHCP. So keep that in mind too. Everything that happens on a network and all the communications are facilitated by protocols. Just like you and I have a language we speak, like we have protocols. In people have protocols. Like when you approach somebody, you typically are saying, "Hello, how are you?" to initiate the conversation. Some of us, including myself, are kind of weird, and I just dive in. But you know what I mean. You have to come to an agreement on somehow, verbal or nonverbal, that we're going to speak in a certain language, right? Whether it's English or Spanish or Japanese, Chinese, Russian, whatever. You have to agree that you're going to speak the same language, right? And then you proceed to speak the same language. You have greetings, right? Those are all protocols, right? Just like in a network, there's protocols that deliver information, and the protocols define structure. They define message types, how big the message is, how frequent. Yeah, DHCP is an automatic. So think about this. DHCP automatically leases out IP addresses. That's what service it provides. So it is a service that provides automatic IP address leasing. And we could do that in Packet Tracer. So Packet Tracer is a simplified network simulator. There are better tools, but you have to kind of graduate to those, I would say. Once you get familiar with Packet Tracer and you get you're starting to feel familiar with networking, I would say then move on to GNS3 because it's more realistic. But this provides everything you really need to know. I got my CCNA. I used some hands-on equipment that I'm actually getting ready to do a giveaway. I'm going to do that next week. I've got some networking equipment. I've also got some servers that I'm going to give away. I'm not using them anymore. Some computer hardware that I'm just going to, and I'm trying to figure out how to do that in a secure way where I can kind of like maybe put them up on a platform that allows you to go claim them, and I'm not selling, I'm giving away. So, I'm trying to figure out the logistics of that, but I have some equipment, networking equipment and computer equipment that I think people out there that are trying to learn can really benefit from. Since I'm virtualizing just about everything I'm doing now, all I need is more RAM and more processors. But yeah, I don't really need more hardware. So just throwing that out there. But what is it? So let's look at the basics. Once you have this set up, what you'll do is you'll notice that this has got like a canvas. This is your diagram. I call it the canvas. This is where you can drag and drop all these devices. All these devices down here are categorized. So you'll notice network devices like routers, switches, hubs, wireless devices, security, right? Firewalls and stuff, and WAN emulation. So there's some, this is actually a multiplayer application too. I could connect my packet tracer to yours, and we could kind of like build networks together in Packet Tracer. Not bad for a free tool. So the first thing you want to really start with, yeah, it is dope, isn't it? And feel free to go through that class too. They could help you kind of get acclimated. I just kind of want to give you a boost, or give you a just launch you out into an understanding, and just get you started. Because sometimes that's the hardest part, is just deciding which way should I go. So I'll show you, and we'll start just talking about the basics. And feel free, anybody in the chat, feel free to share and to provide perspective as well. I'm always open. This is a community. To me, this is, even though I'm the one streaming, you can also be teaching. So feel free. I just, please don't put any malicious links up there, and try not to get too mad at each other. All right. So, the first thing you really need to understand about a network is that there's a bunch of devices that are connected somehow, right? Or a couple that are connected somehow. Think about at your house, or wherever you live, or wherever you go, libraries, schools, office space, wherever. There's a network there. How do the computers connect to the network there? That's one thing I always think about, and I'm a dork, so I look at, when I walk in PetSmart, I look for their server rack. Or when I go in Target or wherever, I'm like, where is it? Because there's a network everywhere. We're just relying on computers. And I mean, we've gotten to the point where computers are the tool of productivity. It's also our way of communication. Think about it. It is the modern form of communication. We used to do what? I mean, pigeons. We used to send messages with pigeons. You used to actually have to jump on a horse. And then let's even go further back. You had to run to go catch up with somebody, right? Or to go deliver a written message to somebody, you had to run. Think about how militaries got messages across. Or you had to, right. Telephone is something that's happening, is becoming a thing of the past. But yeah, telephone, of course. Yeah, that was called the PSTN, the Publicly Switched Telephone Network, and that's why when you look up and you can see the old electrical infrastructure, the power lines, it used to be more popular for messages to pass over those too. Those lines are run right next to the electrical lines. So that's a good point, Hanny. So that was long ago, and now we're at the point where everything's got an IP address. So we've got, if you look at your router at home, if you've got one, and I'm sure you do because you're on this stream now, unless you're watching on your phone and it's a cellular thing. You're connecting usually the same way. Same thing with like your cable TV. That used to be a completely separate connection, but now everything's either going over coaxial or cable or fiber, right? Because really there's those three main types of physically connecting. That is like your copper wires, which is electricity being sent across a copper wire as the conductor to its destination. Then you have fiber, which is amazing. Fiber is either your data is being reflected inside of glass, or lasers. Fiber is also, has laser technology that sends data. And then there's wireless. All three of those are mind-boggling to me. And I really, a lot of people don't look at it this way, but I really attribute a lot of the innovations we made in networking to Tesla, Nikola Tesla, because he was just ahead of his time. Let's look at him. You guys know who Tesla is, right? I'm not talking about the electric car company, even though I really think what they're doing is very cool. Yeah. So, like, if you think about it, Tesla really made all this possible with electromagnetism, and the way he was able to figure out how to harness electricity. Like, for me, I want y'all to think about this. Sometimes, and I know this is just kind of fun knowledge to have, the practical stuff is like what I'm going to show you in your configurations. Oh, wow. That's awesome. So I pull him up because, and I think most people know who he is, but I pull him up just because it's amazing to sit back and think about, okay, yes, as IT professionals, as IT people, as networking people, as cybersecurity people, a lot of the time we're really just using the technology, especially in IT support. There's not a whole lot of invention. There is creative thinking, but with networking and IT support, we're just really good at using the technology that's already been invented. I can't imagine trying to picture this prior to it even having a foundation. So if you think of like what Tesla was talking about and pioneering, that was harnessing electricity to pass information. So for me to think about that, even just with physical connections, like physical Ethernet cables or a physical coaxial cable, which is that cable running out of your router, that real tough cable that runs into the wall, that's coaxial. Information is being packaged into electricity. Yes, I'm not making this up. That's how it gets there as fast as it does. So if I can do something like visual trace route, you can like trace your route all the way to, Google, and it will show you where it goes. Like, usually Google has data centers everywhere, so it doesn't always have to go back there. The request doesn't always have to go back to Silicon Valley. But still, just thinking about the miles and miles and thousands of miles that your data is traveling within milliseconds is all possible because it's being encoded into a form traveling over electricity. So for me, that's like, at some point when my request comes from my search engine to the server, as fast as it just did that, like, look, let me just go back here and I'll click on Wikipedia. Look how fast this happens. Even if it took longer than I wanted it to, that was fast. If you think about it, where is this website actually? Where was this HTML code at? You know what I mean? Like, it wasn't in my house. I'll tell you that. It probably wasn't even in my town. So that information, that request traveled through the network interface controller, which is a USB NIC. I have a USB. I'll show you what that is. A USB NIC. So I connect, this, and my cable and my router sits on my desk. So it went through there, through the modulate. There's a modem in every adapter. It's a modulator, demodulator, and converts it to a electrical pulses, really, because the machine speaking ones and zeros, but it really travels across the line, in the form of electricity to the router, to coaxial cable, to the wall, to the street, and you can see the kind of like the route it takes to get to the ISP. You know those like green electrical boxes you've seen in neighborhoods or whatever? I mean, that's where data is traveling. The data is traveling to those. And usually if you're in a neighborhood, you're sharing that connection. There's better pictures in this. I'm sorry. I just think it's good to start with understanding physically how this is kind of set up. There used to be a picture that was up here that would just look really good. So you get the gist. All right. Hey, keyboard, how you doing? So it's traveling in electricity, but also think about this. There's those two other ways. So one way that it travels is through electrical pulses, and that's usually through copper wires. But then there's the more fascinating, in my opinion, because that alone is fascinating. You can get data to travel in electricity. I couldn't even begin to think about that. Because it exists, I can read about it and I can understand it. But could you imagine realizing that for the first time? You're like, I wonder if we can pass things through this highly dangerous substance or phenomena called electricity. You know, it's like, I couldn't even begin. I wouldn't even want to try it. That's dangerous. I'm looking at lightning and I'm like, that can kill you. So like for me, I mean, just thinking about that's incredible. Yeah. And so the other ways, fiber. Fiber is the fastest way you can connect right now on a network. Fiber is, let's look at a cable. So you see what's actually inside of fiber is a material that's called glass, right? And glass, it's a little glass, what they look like as hairs. Here we go. There's a good illustration. And inside of there is really reflections. You know how mirrors work? You know, the data is being the information is being passed in the form of light. Yes. Your data is traveling at the speed of light through this cable to its destination. There's also other types of fiber that use lasers, laser beams to get data to travel. Yes, in true Star Wars fashion or true sci-fi fashion. And then let me tell you this, and Tesla was big on this too. And this is, for me, the most fascinating thing about the physical aspects of networking. And that's physical as in the cables and all that. And that is wireless. And this is something I don't think we're amazed by enough. If you step back and you really think about wireless, what you're trying to tell me is my data is traveling through thin air? Are you saying that you're saying a message can pass from me to you through thin air? He's a witch. Burn him at the stake. Right? I mean, seriously. Back then, how in the world could you have imagined, like, that's why they really ostracized Tesla because of some of the, because of some of the things he was saying. He seemed kind of crazy, man. Like, dude, you seem kind of crazy. You're talking about sending stuff through the air. What do you mean? This is not possible. There's no way. We can't even see it, right? That's called the radio frequency. Yeah, the electromagnetic spectrum. There's this thing in the air, right? This hierarchy of frequencies that allow us to that allows information to travel. So like that's, for me, that's the most amazing, one of the most amazing technologies that we have right now is wireless. I mean, I know it's been around for a while now, but to just think about how it works, like I can tell you how to connect to Wi-Fi, I can tell you some of the vulnerabilities in the protocols and the authentication, and but I can't tell you how to begin to think about how it was invented. You know what I mean? How in the world do you begin to even try to make this a possibility? You know? Yeah. And we still haven't quite got there yet to what his revelation was in terms of passing power. I mean, we can put our phone down on the pad and let it charge, but that's not quite what he was talking about. I mean, he's talking about you're at a distance. Yeah. Amazing. And that's the future, and that's what's happening right now. You look at the Tesla car, right? Tesla's an Elon Musk company. It's like a rolling phone. I mean, in my opinion, Tesla the company is the new Apple, meaning that's the new innovator in the in our world and in technology. That's a personal, really it's the new personal computer is the Tesla. So yeah, I mean that thing connects to the cellular networks, which are wireless. The cell networks are the wireless network, are the wireless access points for the internet. So you see all those cell towers, those you're connecting to wirelessly, and usually you never disconnect from those. And there are some really fascinating opportunities in that realm as well. Yeah. So I don't know. It's amazing. So that's really where I usually start, is just kind of stepping back and being amazed by networking and how where we're at right now. It's really an incredible feat that people have been able to reach with networking. And now it's matured to the point where we have tools that allow us to practice and configure and even just seamlessly connect, you know? So back into Packet Tracer, which is our network simulator, you can see this, evidence of this. Let's make a couple connections. So I'm going to go over here to end devices, which are devices on the end of the network, meaning they only have one connection to them. Yeah, you should install it, Hanny. So I'm going to drop a couple PCs in here. In Packet Tracer, these PCs don't run a full-blown operating system, but they do simulate Windows. I'll show you why I know that. When you go to command prompt, it identifies the drive letter with C. So that's definitely a Windows thing. So you can imagine you're going to be doing Windows commands like ipconfig and stuff. So you can see. So drop a couple PCs in there, and you can even copy and paste. So I could Control C, Control V, and duplicate. Every network that is got a that has physical connectivity has a switch somewhere. Even your router at home has a switch on it. So your router at home is actually doing a whole lot more than being a router, unless you all have specifically bought different sets of equipment that do different things. So think about all the things your router at home does. It routes to the internet, which I'll talk about what a router actually is. It also switches traffic, meaning connects devices on the same network together. And it also connects you wirelessly. So it's a router, it's a switch, it's a wireless access point, and some do a whole lot more than that. Some actually allow you to do a media server. Heck, it has a web server on it, right? When you type in the IP address of your router in your browser URL bar, it'll actually take you to a login page. So that's got a web server running on it. Yeah, there's a lot that you can do with a router now. So, and we'll talk more about that when I start getting into virtualization stuff. You'll be fascinated by all the things you can do now. You really don't need your own dedicated router anymore. You can run it on a server. Yeah, like routers on a network or in a data center, And in bigger companies, you start to see more specialization. So you'll see like a router, a switch. You'll see wireless access points throughout the building. You'll see phones. You'll see all types of different things. So yeah, that's a great point, Dave. Is looking at it like that is, the bigger the companies are, the more they need dedicated devices, not only for performance reasons, but also security and then distance, right? Because if you have multiple buildings, you're going to need equipment to help get the electrical signal where it needs to go. Remember, this is really about controlling the flow of information, which is in the form of an electrical signal, and also securing it. Yeah, when you think about the network, think about highways and streets to get to the locations they need to get to, So networking is just as important as all the others. So, all right, we see PC, both of them. Let's make connections. So I'm going to go ahead and go to network devices down here on the bottom left. And it took me, I didn't actually know this for years. This is a search bar right here in Packet Tracer. So I can search for a switch and switch will come up. It's crazy. So I don't know why I never used it until recently. So we go up here into network devices, which are devices that connect other devices together. Notice that these on the top row are the categories. Below are the actual types of devices. So I'm under the category network devices. I'm going to click switches. Go to the 2960, drop that in the topology. I'm going to zoom in so it's easier to see. Move myself up a little bit. So you can see here, what do we need? I mean, think about what you need on your network. You need a physical connection. And most of us, like we said, are connected wirelessly. But when you start to get into business environments, you will see that they have physical connections. I think maybe I'm wrong, I'm always open to being wrong. But I think we're always going to see some form of physical connectivity. I don't think wireless is going to be able to catch up ever in terms of speed. I don't know if from a physics perspective it's possible to make wireless just as fast as fiber. Do we know of anything that travels faster than the speed of light? Or even copper wiring. Some of the newer copper wiring, can do gigs. Like some Cat 5 and Cat 6 and Cat 7, like it's starting to get to the point where even Ethernet or wired Ethernet is fast. It's like super fast. So we're going to go ahead and now make some connections. Because remember, on a network, you need connections. You can't just have the devices. So whether it's wireless or physical, we're going to do physical. So this wire, click on it. Go to fast Ethernet. Notice how in your Packet Tracer PC you have ports. They have USB. I haven't done a whole lot of stuff with USB and Packet Tracer. We go to fast Ethernet. I click on that, and it sticks to your mouse. Drag it up to the switch. And what is a switch? Does anybody know? It is a device that facilitates communication on a LAN. LAN, I'm sure you've heard. Back in the day, they used to do LAN parties, which are coming back in the form of these big competitions that people are going to. Think about it. Have you ever been to an esports competition or seen one on TV? That's just a ginormous, formalized LAN party. It's cool. I love the age we're in. But a LAN is a local area network, meaning a smaller network. And, small could be a college campus. Or small could be a building in a college. But really, I think about it as like your home is a LAN. It's a local area network. So a switch connects computers together on a LAN. So there's a central connecting point for all the devices. It used to be the case where there was a long cable. Let's look at it. Yeah, bus network. This was old school. They used to connect devices all on the same cable. So it used to be where they just just plugged into the same exact cable. But the problem with this was if something broke here, use the 2960 switch. I picked the 2960, I think. I just grabbed one. It doesn't matter. Just grab a switch. It really doesn't matter which one you grab. If this cable went down, the whole network went down. So no one had any connectivity. Now we're living in the age of the star topology. So this was a bus topology because it was just one connection that the signal traveled across. Now we're living in the age of the star topology. So star meaning there's a central connecting point for all the devices. So if I create that connection, yeah, this is a 2960. This was just cutting off. The line was just cutting off the 6. And you would connect this one as well. So now if you think about that compared to what we just looked at with the bus, if this connection goes down, at least this PC still gets to connect. It doesn't take everything off the network. So that made a lot more sense. A lot of people like to call this topology a hybrid because while it's a star, you think about the logical connections. The logical connections is really how the electrical signal travels on the wire. So once it hops onto the wire, it connects to the switch. Inside of the circuitry of the switch is actually a bus. So it's shaped like that. It's shaped like this. On the inside, it just stems off to each port. So the bus has moved into the switch. I don't know if any of you knew that. So the bus topology is inside the switch, but the overall topology is a star because there's a central connecting point. So I chose fast Ethernet just because most modern enterprise switches are actually 10100 going to the clients and gig going to servers. You'll also see switches that are doing 10 gig to the servers. But in my experience, what I've seen mostly, and maybe it's just in my area, is the switches that are installed on their infrastructure are fast Ethernet, which is 100 megabits per second to the PC. So even though the PC's NIC is capable of a gig, it's not getting a gig because the port speed on the switch that it's connected to is 100 megabits. So that's something to think about. But yes, there are also all modern switches now, when you buy them, are coming 1 gig. But a lot of switches, enterprise grade, they figure why do you need gig to the switch? Reserve that for your more critical devices. But yeah, I would recommend, if you can, get switches that are all gig ports. So yes, we got our physical connections. Now we need our logical connections. And what that is now we need to start working in software. So what do we need to do within software to be able to communicate on a network? If you guessed IP address, you're right. We need an IP address. So how do we do that? We don't have a DHCP server right now. I usually start with doing static IPs because I want you to feel what that's like and how it could be really not a good idea to manage static IPs on a large network because you have DHCP. So I'm going to show you this just so you get a feel for assigning an IP address and you understand what DHCP is doing automatically. So on these PCs, we're going to need to give them an IP address. And this is where a lot of people struggle with networking, and where I struggled with networking at first is with IP addressing. So Hanny, the switches, you go to network devices and then go over to switches. Click switches, and I grabbed the 2960. So once you've got that set up and you've got these connections made, we're going to give some IP address. Oh, in real life. Okay. The switch is usually in a closet, a telecommunications closet, or a server room somewhere locked away so that somebody can't take a Raspberry Pi, plug into it, and start wreaking havoc on the network. Yeah, so you can follow cables and wired connections to where that is. So if you're looking at you're sitting in the library or something and you're looking at the back of the computer, you're probably going to see a cable running somewhere up into the ceiling, it's going to be off into a server room somewhere, whether it's in a closet, a basement, an attic. It's going to be in the server room, usually. And a lot of if it's like a college campus or a corporate campus or a building that's big enough to have, they need what's called IDFs, which is an intermediate distribution frame. I'll show you this. You might have walked by one. You heard the fans going. So usually, if it's a big enough organization, they'll have one of these, which is really just a checkpoint for that electrical signal. It'll have switches stacked. Here's a patch panel. Usually your IDFs, they can have servers in them, but they usually just have switches and routers because it's just allowing you to either connect to the local network near you or just shooting it off to another building or off to the internet. I mean, really, an MDF, which is the main distribution frame, is where your internet connection is going to be, or your router that connects to the internet. So this is looking at it from a telco perspective. But in a building, like a college campus, they're going to have servers in there, but they also have routers. And it's really up to the network admin and the IT team on where they want to put servers physically on the network. So you don't have to put them in the IDF or you don't have to put them in the MDF. It's up to you. So, so usually the switches are located in a business environment. Usually they're located in the IDFs and the MDFs to terminate the cables and to make the connections between the computers on that network. And a small businesses their networks look a lot like our home networks because they don't really have enough devices to really constitute having their own separate switch. And by the way, the network architecture you have at home, usually most people have at home, would be considered a flat architecture, meaning, everything just goes to the same device. There's no redundancy, which in networking, redundancy is a good thing. Usually if you hear someone say you're redundant, that's an insult. But in the networking world, redundancy is good because you can have backups for your backups, and you can have secondary connections that come up when they're needed, but a flat design also is risky because if something starts malfunctioning with your router, that's going to affect your wireless network. That's going to affect your connection to the internet. That's also going to affect your connection to other computers on the network. So most businesses aren't going to just do that. They're not going to say, all right, everybody, just connect to the router. They're going to have more of a hierarchical design. So they're going to have devices that are dedicated for specific tasks. So here we have our network, right? And what we were getting ready to do is connect them together. So let's get ping working. How do we do that? First of all, we need an IP address. So we can go over to this PC, click on it, go into IP configuration. You guessed it. Oh, and by the way, you can swap out like network cards on this PC and stuff and turn it off and on. So it's okay. It's pretty cool. Yeah. Yeah. Yeah, that's true. It's not. Like they'll say the internet's down. But you have to think, okay, well, how are they connecting to their network? That's where I start. Because the internet, likely that the internet's not down, but hey, these days it can happen. Amazon Web Services can get DDoSed, which a lot of services are hosted on AWS now. So if AWS has a whole region that goes down, then technically the internet is down. But for the most part, the whole global network that is the internet is not down. And by the way, the internet is the collection of connections, routers, and switches that in the cables. And when I say connections, I mean cables that make up the internet. World Wide Web is the collection of web pages. So know that there's a difference. There really is a difference between the internet and the World Wide Web. When you hear the World Wide Web, think about web pages and web servers. When you hear internet, think about routers, switches, cables, and fiber and all that. So, all right, let's give this thing an IP address. This is, as I was saying earlier, this is usually the hardest thing for most people to pick up, especially when they get into subnetting. I know I struggled with subnetting. But really, when you hear somebody say, what network are you on? Most of the time, they're not going to be asking you from a physical perspective. They're asking you from a logical perspective. Anytime I use the term logical, I mean in software. Because with physical and logical, physical, we have physical connections. Logical, we have this way that the signal travels, as well as addressing. So when like a system needs to have an address, an IP address, to be able to connect to a network. And currently, IPv4 is the most popular protocol still. Since like the beginning of the internet, IPv4 has been around. And there's some security issues with that. Because we have IPv6. IPv6 has been around for over 15 years. And it's still not the dominant protocol, even though it's better in every way. I mean, changed my mind. So we can look at the IP address here, and let's go ahead and I'm going to pick a basic IP address. I'm going to pick a Class C private IP address, and you've probably seen this. It's 192.168.0, and I'm going to start at 10. Usually I reserve the first 10 addresses for like servers, routers, switches, and all that. Usually you can go, I go higher than that, but in this case, we're just going to start at 10, just a habit. When you tab or go down, it automatically fills in the subnet mask. What I want you to understand about this, and this is a very important point, is that the IP address is like a phone number for your computer. Just like your phone has a phone number. It's weird. It's weird now. Your phone has an IP address too. Your phone has a phone number and it has an IP address associated with it. So, this is like a phone number for a computer. Think of that. The subnet mask gets a little bit more complicated in terms of what it means. The subnet mask defines what portion of the IP address is for the network and what portion is for hosts. So the network portion of an IP address has to match on all the computers on a network. The host is going to be different. You can't have the same IP address as somebody else. You might argue and say, well, what do you mean? Clusters share IPs. Well, the network interface controllers or cards on each of those systems have different IPs. You can't actually have the same IP in it and it not conflict. But that for now, starting off for now, just use that standard subnet mask, which is 255.255.255.0. I've got a video on YouTube where I cover IP addressing. And I was doing this every now and then. I'll do it on stream too, because it's a tough concept for people to get. Feel free to jump in the Discord as well and ask me questions. I've got packets that I that I have, that I've written, that are really, I try to make them fun to read and stuff, and I could help you understand it that way. I really do want to write kind of like a good documentation, a good book on it, maybe something that we can host in GitHub. So subnet mask 255.255.255.0. We got the IP address. We're good on this one. We'll talk about default gateway later. I don't like to drop too much on you at once, because I don't like to have a whole bunch like, oh man, a whole bunch of knowledge just like in the wrong order, or not in any order at all, is just like chaos for me. I really can appreciate when knowledge is curated and when knowledge is given in a way that's got order to it. Yeah, feel free to. I'm working on more and more. I want to have a whole entire CCNA course for free on YouTube by this summer, by June. I want to have it all done. And I do need to go back to some of the intro stuff. The reason maybe, Handy, you're not finding those intro videos is because of I haven't put them in a playlist in the order that I've meant the videos to go in, because I haven't finished that series. I'm releasing that in increments. I felt forced to, as the coronavirus, started happening. I felt like I had to start putting out videos that I was working on and that I had finished, instead of releasing it as an entire completed series. So I will eventually have that in a playlist, and you'll be able to say, oh, start here, go here, go here. Because I like that, to curate education, so one builds on top of the other. So, okay, we're on this PC, got a IP address. Let's go to the other one. So we'll go to this PC, go to desktop, IP configuration. I'm going to give this one 192.168.0.11. And if I hit tab, it auto-fills with that standard Class C subnet mask. So now, there's something I always like to do in IT in general, and that is confirm. And this is true for even pen testing, I'm noticing, is in security, is confirm. So yeah, I said it and all that, but let me make sure. So I'm going to go to command prompt, which in Mac, you would go to terminal, and you would do the command ifconfig to check your IP. So in Windows, you do the command ipconfig, which is short for, you guessed it, IP configuration. And I hit enter, and it shows my settings. Cool, this is what I'm looking for. Guess what? I'm going to do it on the other one too. So I'm going to go over here to this PC. I'm going to do command prompt. I'm going to do ipconfig. Let's put them right next to each other, these windows, just to make it look better. All right, so they're right next to each other. I've got, I didn't assign this one an IP, so that's why I confirm. Or did I? Yes, I did. It's right here. 10 and 11. Yeah, I think so too. I like it. And look, guess what? Ping works in here. I mean, it's awesome. Watch. So let's ping between this PC that I got on my right side and the PC on the left side. So I'm going to do ping. Does anybody know what ping is? It's got a really weird name. Packet Internet Work Groper. How about that? It's really a program that runs ping.exe. So if you went into, I think it's System32, you would see in System32 a ping.exe file. So ping is a tool. The protocol that ping uses, does anybody know? I'll give you some time. Let me check my phone real quick. Ping uses a protocol called ICMP. ICMP is the Internet Control Message Protocol. Traceroute also uses ICMP. So let's ping. Why do we ever ping? Why should you ever ping? Well, ping is a great way to test that you have connectivity. I usually ask people if they're having a network issue or if they're having issue connecting to something. I usually try to ping it first. And if it's an IT professional, I'll ask them, can you ping it or have you tried to ping it? And most haven't. Now, I will say, in defense of people that don't ping, I will say ICMP, the protocol, is often blocked. Even on a fresh install of like Windows 10, ping is blocked. It's ICMP echo and ICMP echo request is actually blocked on the firewall. You have to allow it. Does anybody know why? I'll tell you why. DDoS attacks. So there's one particular distributed denial of service attack called a ping of death, which is basically a botnet pinging over a network, right? A botnet is like a huge collection of computers that a hacker has put together using malware or something and directed a ping to the same device. That over time has brought down a lot of servers. In denial of service, now we talked about services, is like denying access to a website. So if a web server gets DOSed or DDoSed, then it cannot provide a web page, which is the service that it provides, right? So because it's too busy responding to ping. So a lot of routers and a lot of servers that are especially public facing, and when I say public, I mean that are accessible over the internet, are blocking ICMP, are not accepting ICMP on their network because they would get DOSed. Yeah. Yep. I got a story for y'all real quick, if you don't mind, and then we'll ping. So I used to do quite a bit of workshops at a library near me on networking. Like I had the library buy some basic little Netgear switches, and you can buy one too. They're like $60 on Amazon. I would recommend buying a managed switch though. I've got one, and this is one I'm going to give away. I'll show you. I got a little small managed Cisco switch. Managed means it has an operating system and can be configured, but it's a 2960. You can go, Netgear is fine. You can get a nice little Netgear managed switch, or Ubiquiti is getting popular. I'm gonna change my my filter. My chroma key filter is looking a little off. That looks better, I think. Okay. Yeah, sure. Let me pull up one. I'll show you a couple. In either way, I mean, I'm trying to think of one you'll probably see. You'll probably see, when you start to get into the bigger organizations, you'll see Cisco, you'll see Juniper. Those are more expensive. I wouldn't recommend those immediately. And again, for those of you that didn't hear, I'm looking at doing a giveaway next weekend. I usually stream on Fridays and Saturdays. I'm just trying to figure out what platform I should post this giveaway on so that people can go out there and claim it securely and for free. So I'm not looking to sell any of the equipment I have. I'm looking to give it away. I think it's better that way, right? Comes back around. So we look at so you can look at a Netgear, and I would recommend getting a managed switch because they have more capabilities. I'll talk about that. Just know it'll set you up for future learning. So you can get one of these. These are not bad. And these you'll see on, small, medium-sized businesses. So it'd be good practice. You can get 8-port, 16-port. 16-port's pretty safe. I don't know if y'all have more than 16 devices at home that need a physical connection to them. What else? There's Ubiquiti. So let me give you that one. This is for the Netgear. And then there's Ubiquiti is very popular. And I'll just say their switches look good. They got a nice slick look to them. Here's a Ubiquiti switch. So if you want something that looks good in your house, grab a Ubiquiti switch. But then when you start looking at Cisco stuff, you'll notice it's a little bit more expensive because of the capabilities in software and in hardware, and because of the name. They can charge a premium. They're established in the industry. HP, Dell makes switches. I don't know if you guys knew that. So these are all some things you can get to get away from the flat design. Oh, wow. I didn't know that. I mean, I typically go with Cisco. If I'm going to recommend to a business, I go with Cisco. Cisco, Dell, or Netgear. If it's a smaller company, they may not need a Cisco gear. Meraki is super cool. If you guys have a work email, you can actually get Meraki gear for free if you attend a webinar. I'm serious, and I'm not being paid to say this. I have no affiliation with Cisco Meraki, but I've worked with them quite a bit. I used to work in an MSP environment. They're awesome. Yep. Yeah, and that's a good point too, is you can get equipment for free. A lot of these like school districts, when they get $1 million contracts, they just give the stuff away. The MX, their firewalls are cool. They're basically the Apple of networking, meaning they make it super easy for you to learn Cisco Meraki, or for you to learn networking, really, or for you to set up a network. You still need to know how it works, but for the most part, it's all in a web-based interface. Oh, sweet! I didn't know that. Thank you for making me aware of that. That's awesome. Yeah. We would just set up LDAP connection to Active Directory and VPN using the built-in client in Windows or Mac. That's cool. I'm glad. Meraki's got an interesting story. Group of students out of MIT got Cisco a little bit scared, so Cisco bought them because Meraki's really coined cloud networking, where as they started to come up, they picked a controller in the cloud that you could access through a web browser and do all your configurations on that one controller, and then anytime that router or the appliance checks back to the controller, it pulls in all the configurations automatically. So Cisco saw that as a potential market, small and medium size, that was going to threaten them. And this is my opinion. So they bought them. A lot of the tech companies, when they feel like it could be a threat, they'll just buy them. Oh, no. I was just talking about, what was that? What was I telling? Oh, yeah. Okay, the library. So I used to do, we were talking about Netgear, and I went on a tangent. It's okay, though. It's all educational, hopefully. So I was doing these workshops at the library, and I was talking to the IT director, and the IT director was telling me about an issue he was having on the network where the people working in the office were having like super issues with connecting, and how it was like super slow, and it just was like it was at a certain time of day. And he did some searching, and he had a Meraki MX appliance, and he noticed he would sit down and he would wait, and during that time of the day that everybody was reporting, he would watch and see what was going on. And he noticed quite a lot of traffic being generated from one system. What he ended up learning was that there was a young kid, coming to the library every day, getting on that computer, and using one of these DDoS as a service websites to DDoS the library. So he ended up finding out. And I mean, he could have done that other ways too, but it kind of like the interface in Meraki made that easy. But I thought that, yeah, every day he would do that. The kid would just come in. Just come on. You can get in big trouble for that now. Like, that's not a joke anymore. I mean, you can get arrested for that. Seriously. They'll find you. Yeah, it was a kid. So, let's ping. Yes. And surprisingly, yes. But it's become harder to do it through like ping or ICMP because so many people are now aware of it. So I will say, be careful though. I mean, if you're going to go out there and experiment with any of that, make sure you're using it on your own stuff on an isolated network. Don't target anything over the web. Even if you're targeting, like if you have like on Amazon Web Services and you set up a couple of services or servers in the cloud, even if you do that and you target those, that's illegal, because if you're hitting those systems, you're also affecting Amazon's infrastructure. And on the way, you're affecting all those ISPs. So when I think of a DOS attack coming from like a botnet, I'm thinking of a tsunami. That's a tsunami. Because all that traffic has to get routed over the internet. So you might those tools might take down a few ISPs on the way to their destination. That's what happened with Mirai, the Mirai botnet. That was one of the largest botnets in history that took down Amazon, like regions of Amazon Web Services. I don't know if you guys know about AWS. AWS is cool. Cloud networking. You can basically access a supercomputer. Anybody can get access to a supercomputer now. So I do not recommend using any DDoS as a service. It's nothing but trouble, and you can get in trouble, trust me. Is that IBM Watson? Or is that Watson's are AI, right? Yeah, I would recommend you all. We could do some cloud stuff on here too. I like cloud. I do. I will admit, I am a server hugger, meaning I thoroughly enjoy having a server to manage and do everything on from scratch. But I do acknowledge the value, and I acknowledge the existence and the need for cloud. Summit, IBM Summit. Let me check that out. It sounds familiar, but I don't have experience with it. Oh, this is cool. Yeah, for some reason, when I first started learning IT, networking just clicked. And when I say networking, I'm not just talking about routers and switches and cables. I'm talking about everything that comes with it, everything that comes with connectivity and delivering services. So for me, when I think of networking, I'm thinking of servers too, setting up servers. I think of Linux, because what device now is not networked? I mean, I worked for an MSP, and we supported some companies that were like manufacturing environments. And those manufacturing environments had like PCs that were air gapped, which means they weren't even on the network. They were completely isolated because all they were doing was telling a machine to bend metal or something. It was just allowing the machinist to interact with the machine or allowing the person to send commands to the machine. It didn't necessarily need to be networked. Could it benefit from being networked? Potentially, yeah. Potentially it could. But, yeah, you're not going to see a whole lot of systems that are not connected to a network. So for me, that just means we need to understand it. Me, at least, I really need to understand how it works. If I'm going to support it, I'm going to fix it, I'm going to help with it, got to understand it. So networking can only help. All right, so we have ping here in Packet Tracer. So go ahead and type ping and then do the IP address of the destination. Here's a thing to remember about networking. Just always remind yourself as you're doing pen testing or anything, trying to troubleshoot a connectivity issue or whatever. Know that there is a source, meaning there's a place where the message started, and there's a destination. So there's always a source and there's always a destination. So in this case, our source is .11. Here, our destination is 192.168.0.10. So do your ping, 192.168.0.10. Enter. So it shoots out 4 in Mac. If you were to ping like your gateway or whatever in Mac, it'll, in Linux, ping the command by default, just does it until you tell it to stop. In Windows, the default amount of times it's going to ping is 4. If you wanted to do it in Windows unlimited times or until you tell it to stop, you do a -T flag, which does a continuous ping. Continuous pings are good to test like wireless with distance. Hey, how you doing, Newt Cax? So continuous pings help for uptime. So a lot of the monitoring software, this is essentially what it's doing. If ICMP is allowed, it's just pinging it and then if it can't, yeah, I did. I got it. You know what it was, and you can go back and watch too. I think that version of that PHP reverse shell was not an updated version. So I tried that. I was like thinking about what we were talking about yesterday, and I went out to the site where the GitHub repo where it's stored, and I copy and pasted, and sure enough, as soon as I did it, it worked. And I didn't use curl. I didn't use curl to get to execute the PHP script. I just went to the directory. So that was a fun experience though. And then I got a user, I got the user flag, and I got root. So that was fun. Rooted that bad boy. All right, so we're talking about networking a little bit right now. Just kind of like some fundamentals. We talked about quite a bit. We kind of were enamored by one major thing, and that is the idea that information is traveling in electricity from me to you. Like, think about this. This is blowing my mind. As I talk, my voice, it travels through the air into this microphone, through a USB cable into my computer, then out the network card or network interface controller. Mine's a USB NIC to the router, over the internet to Twitch, wherever the node is, then off to you guys. And that's probably on like maybe a 5-second delay. How amazing is that? That's audio, video, everything. The chat is more immediate because there's less to carry, right? So that to me is just amazing. Yeah, it's exactly like that. It's exactly like that. So we're pinging, got the ping working, right? And that's just congratulations, Hanny. You just built your first network. So it's built. Now there's more that we can do. So remember I was talking about DHCP earlier. Go ahead and go down here to the end devices. Go to your server right here. drop it in there. Hey, don't discriminate against servers. Servers need IP addresses too. So we go to desktop, then IP config, you can do 192.168.0.5. Give it a subnet mask, it's already there. I'm not giving it a default gateway. We haven't got to routers yet. And then do IP config, 192.168.0.5. It's there. Let me just make sure I can. Actually, I don't need a ping because I'm going to make this a DHCP server. So I'll show you. Remember, we've been talking about services. So in our network neighborhood, just like a neighborhood and a community has services like fire departments and sewage and water treatment and all that, a network neighborhood has services too. Web servers, DHCP servers, file servers, DNS servers, lots of things that we're going to talk about. Oh, thank you very much. I appreciate that. Those are kind words. Thank you. You're a blessing as well. So, we go into services. Under DHCP, we are going to set a scope, or in the Cisco world they call this a pool, but in the Microsoft server world, I'm gonna change my chroma key because I'm getting a little grainy. There we go. In Microsoft calls this a scope, which is the same thing. It's a list of IP addresses or IP address leasing information. So DHCP is leasing out addresses automatically as requested. So let's start at 10. Leave the first 9 to be assigned, right? And then if I want to account for a router, I would say 192.168.0.1. That's what my router IP would be. And then I'll save that. And I'll turn it on. Don't forget to turn the service on. Now I'm going to go to these PCs. Oh, also, don't forget to make a physical connection. I'm going to go to these PCs and I'm going to tell them to get an IP address automatically from DHCP. Go in here. You do IP config. Flip over to DHCP and watch what happens. This actually needs to finish converging before this works. But this is a good point. If you've ever seen that 169 address before, that means that the computer, the PC, gave itself an IP address because DHCP did not respond. Now, if I were to go back static and then DHCP, it will then probably respond. So we go static, DHCP. There we go. See, it got an IP address. It got it automatically. We didn't have to statically assign it. This is how it's happening right now in the industry. This is how it's happening at home. You're getting an IP from DHCP that's running on your server. Make sense? Let's see, what else? What else may we be able to look at? There's so many things here. I mean, there's a web server on this. Look at this. Go to services and HTTP. I mean, it's nothing serious. It already has HTML files on it, and it's on the service. So what does that mean we can do? We can open up the browser. So if I hit exit there and go to web browser, we would actually have to type in the IP address because we don't have DNS running on this network. That can be the next thing we do. So we go to server. DNS. Oh, I'm sorry, we're not doing DNS yet. I'm looking at my IP again, 0.5. So remember, if I'm looking for a website, I need to target the destination because that's what we're doing on the web anyways. We're just using domain names to get to, like when you go to Twitch, you're going to twitch.tv or you're opening the app. And all your app is, think about it, all an app is a shortcut to a website. So we go in the URL 192.168.0.5, enter. and it delivered the web page. Let me show you something. This might blow your mind. If you want to really get in depth on what's happening in the background, which you should, always be curious. Don't be afraid to be curious, by the way. Fear of failure is the greatest enemy of learning, in my opinion. Failure really just stands for fail. I don't know if you ever heard this. Fail really just stands for first attempt in learning. So if we go over to simulation, watch what happens when I generate. Actually, I'm gonna explain what simulation mode is. So simulation mode allows you to watch what happens in the background with the protocols and the packets as your message travels. It's awesome. So I'm gonna remove all the filters. All I want to see is HTTP. Let's see. Yeah, all I want to see is HTTP. And S. Maybe we'll look at both. Because I just want to watch those two. This is like the equivalent of Wireshark. It's a simulated version of packet analysis. So now that I'm in simulation mode, I can start that message again. Like I'll go. I hit go there. And as I skip ahead, remember this from the days of the DVD. Remember scene selection before it was a live stream or a streamed video or a buffer. You actually had to skip scenes. Here, a packet's been generated. Anytime you send traffic, right now, my voice, every time you hear noise or see anything happening live right now, right? To be honest with you, live stream events are the most resource intensive thing in networking because of everything that's happening at once live. So I happen to know that Twitch is using the real-time message protocol, and we could look at that in Wireshark too, seeing what packets look like as I'm talking. And so what you'll see here in Packet Tracer is I've just done a simple request for a web page, which is an HTTP GET request. You can see that request. You can also see inside of the packet, you can see what are some of the destinations, right? So outbound meaning where's it going? We know the destination header is the IP address of that server. And then the source is the PC. So watch this. You skip ahead. You can watch it go to the switch. And then it goes into the server. And we can see what does it look like once it gets to the server. So we noticed it's a port 80, right? TCP port 80 is the destination port. That's for HTTP. That's pretty widespread. It's a common port. And then the destination's 5. What's going to happen, though, as it goes back out, this is going to repackage that message, and the destination and source are going to flip. So this is going to become the destination, and this is going to become the source, even though this was the originator. So it sends it back, says, hey, guess what I put in here? Guess what it also sends back? The web page, right? Because that's what your web browser is. It's a client requesting a web page from a web server, and the web server provides a copy of it. It's probably coming from a proxy, honestly, because most sites don't want their source code being stolen. Yeah, it's going to return HTML, a directory of HTML, really, a page inside of this packet, and it's transferring it using the HTTP protocol. Goes back down. Remember, IP is always used. The internet protocol is always used. And then it receives it. You look at it, and here it is. Cool, right? That's a different way to learn it. That was the equivalent of doing this. I'll open up Wireshark. I'm probably going to give away some IP address information, but I'm not too worried about it. So Wireshark, has anybody ever heard of Wireshark? This is another free tool you should go out there and download. It's free on Windows, free on Linux, free on Mac. It is incredible. Let me just say, this is not a simulation. This is not a drill, people. This is real traffic being captured in real time. What Wireshark does is it puts your NIC in promiscuous mode, where it actually starts to capture everything that's destined for it and everything that leaves it. Yeah, absolutely, Dave. So Dave mentioned a great point. It's already in a lot of distros of Linux. So if I were to open it up on my Ethernet connection, watch this. This is what's happening live right now. As I'm talking, it continues to generate real-time message protocol packets that send from here to this destination, which is Twitch's IP or whatever node I'm streaming to. I'm always fascinated by, and I always want to know how people's infrastructure is set up. Can you imagine how awesome Twitch's network infrastructure is? Their server infrastructure and all that, to be able to support live streaming 24 hours a day. You know? And it's pretty much without a hitch. It's pretty much without a hitch. Yeah, you can see whatever traffic you want, really. Like, I'm interested. You know, here, can I give you guys a pro tip here? Whether you're looking for a job or you're just wanting to know what technology a company uses, I'll tell you what you do to find out. It's not a secret. They hire, don't they? And they post those jobs. Look at the job description.